In this video, we're going to be talking about the speed time graph. Because this is slightly more complicated than the distance time graph, it gives us more that we can be asked about in the exam. So when we have speed and time, we need to be familiar with the journey that this graph would represent. So going from 0 to here is accelerating. This flat bit, everyone always says that this is where it stopped because it's flat, but that's for the distance time graph. Here, we would be traveling at a constant speed, or a steady speed, I guess. Like say 50 miles an hour, we stay at that speed, like on a motorway or something like that. Then you're staying at a steady speed. We accelerate again to this point, and then we start to decelerate until we get to stopped down here. So these 2 points here are actually when this object has stopped. And the features of the speed time graph that we need to be aware of is that we can calculate the acceleration by doing the change in the speed. So from here to here, that's a change in speed. So we subtract the new minus the original. Okay, but essentially we're working out the gradient, rise over run. Okay, so just try to do rise over run, and that will give you the acceleration. And if it's a deceleration, this should be a negative number, okay, because the gradient is dropping. The other features that we need to be aware of are, if I split this graph into chunks like this, and I work out these areas, when I add them all together, this will give me the total distance traveled. So we can work out the distance that this object has traveled by working out the area underneath the graph. Okay, so we've got a triangle here, rectangle, a trapezium, and another triangle. If you're not too comfortable with the trapezium, you could split that into another rectangle and another triangle like that. But essentially you would add up all of these areas, and this would give you the distance. Because they often ask you what was the average speed. Okay, the average speed. You can't just say this was 50 and this was 100. So I'll take the average of those and that would be 75. It doesn't quite work like that. We have to work out the total distance by doing all of these added, divided by the total time. That might be like 3 hours or something like that. Then that is how we work out the average speed. So distance is the area under the graph, acceleration is the gradient or the deceleration, and this constant speed feature of the flat part is something that always trips students up. So try to avoid that mistake in your exams.